Okay.
You should.
All right. So when graphing the reciprocal functions, all you guys simply need to do is, again, it's a very redundant step-by-step basis. All I want you guys to do is think about, just focus on graphing the reciprocal function. From the reciprocal function, we will graph or from the reciprocal function, we will graph cosecant. So when graphing sine, you need to remember all the information we talked about, which it should be in your notes, right? So all should be in your notes. Amplitude, right? Well, in that case, that's 1. Period is 2 pi divided by b. And if you guys remember where these came from, this is y equals a times sine of bx minus c plus d, right? I gave you guys that. That's also in your notes. So 2 pi divided by b. Well, the number in front here.
So, yeah, I thought cosecant and sine were opposites.
Yeah,
Wasn't
those are
sine
opposite.
2 over x?
Sine's 2 over x.
Huh?
Cosecant is opposite. So what is?
I know they're reciprocal. I'm just telling you what I'm telling you how to graph these. You're correct. What I'm telling you how to graph them is just graph the other function, the reciprocal function, for the same values. And I'll explain. OK? So because we don't have, yes, if you were like to type it in your calculator, if you were going to type this in your calculator, you would do 1 divided by sine of x divided by 2. That's how you type in your calculator. But we're not graphing using our calculator. We're going to graph using just how we know how to graph. So the next thing to do is 2 pi divided by b. b, remember, is what's in front of the x. In this case, our b is 1. 1 divided by 2. So in case, what we have is 2 pi divided by 1/2. Multiplying by the reciprocals will give you 4 pi. Does everybody agree with me? Your x scale is your period divided by 4. 4 pi divided by 4 is pi. The next thing is your phase shift. Phase shift is going to be, remember I graphed the initial period. The initial period technically starts at 0 for sine and cosine. So if we're shifting it at all, we basically, that's our phase shift. So all you do for that is do bx minus c equals 0 and see what the value of x is. Well, in this case, I have x divided by 2 equals 0. So when I solve, I just get x equals 0. So therefore, there is no phase shift, right? It's going to start at 0. And then the last one is my vertical translation. I'm not adding or subtracting anything. So that's none, right? When you add or subtract outside the function, your d, that shifts it up or down, there is none. So now all you're going to do is just graph sine, just like you know how to do. So the way that I graph, since I'm starting at 0, Logan asked me to do a period to the right and a period to the left. So we're going to start at 0. At 0 is the y-axis, right? Here's the x-axis. The scaling, instead of doing 1, 2, and 3 like a normal scale that we do, my new scale is going to be pi. So pi, 2 pi, 3 pi, 4 pi. Now, it does say to do 2 periods. So you either do 2 periods to the right, or you could do a period to the right and a period to the left.
I like how you saved that too.
OK? Now, what does sine look like? I already graphed this, so is it OK if I don't graph the parent function again? So now the amplitude, again, is 1. So I'm going to go up to 1, down to 1. So it goes here to the max, intercept, minimum, max. OK, then this one follows a pattern up here, up here. Does everybody agree with me on this? So then the only thing new that we taught last class period, see, the only thing different now, this was 2 class periods ago. Graphing all this. So this is all in your notes. Same process. The only thing new to graph cosecant, see, cosecant's in the red. I haven't even graphed cosecant yet. I've just graphed sine. To graph the answer for cosecant, every single time your graph crosses, that is an asymptote for the cosecant function graph.
Now, would it be the same if you had a cosine?
Mm-hmm. Yep.
Secant?
Yep. And then at every max and min, they share a point, but it now is parabolas. entering the other way. And the red is what is the cosecant graph. The black is the sine graph that I just used to help me graph this. Does that make sense?
Yes.
Yes.
So now, cosecant is supposed to be the reciprocal of sine. So is that kind of what is that what you showed in the red?
Mhm. That is the reciprocal. This is the reciprocal graph. OK? Yes. Yes. Okay. Huh? The x-axis. It's an asymptote of the cosecant function. Because think about it. Remember sine is, or I'm sorry, sine is y. So that means cosecant is 1 over y, right? So if sine is 0, what's 1 over 0? Undefined. You can't divide by 0. Yes, Meadow.
If we just drew like the red instead of doing like the dotted first, would it be red?
Yeah, you don't have to do this, but I mean, this is very helpful for me as far as teaching it, as well as understanding where this comes from. But yeah, in reality, see how I did this black is dotted? It's not a part of the graph. It's just, I'm just using it as an aid to graph.
What if we made it solid? Would you count it wrong?
Yeah, I would mark you down because it's not part of the graph. So you will want to make sure that you either dot it or make sure you say that, hey, this is not a part of the graph. I just used that as an aid. Yes?
Okay, so you want us to dot the black one then, but what about the asymptotes?
Yeah, those are dotted, but those are part of the, I mean, asymptote is really not a part of the graph. It's really what it approaches, but yeah, you still include the asymptotes. Yes? OK, now let's just talk about a couple things here real quick, because we have gone over domain and range before. So I really want to make sure I hit on these points. The domain. Now, the domain is all real numbers. I'm not going to do a fancy notation for this right now. Domain is all real numbers, except for the asymptotes. When does the first asymptote occur? 0, right? And then when is the next asymptote? 2 pi. How far is it to the next one? 4 pi. Well, what's the distance? 2 pi. So I just can keep on adding 2 pi, right? So therefore, I could say where x cannot equal, I'm just going to include 0, but 0 plus 2 pi. How many times could I add 2 pi? Infinity. So what could I use to represent adding 2 pi? None. 1 time, 2 times, 3 times, all the way up to infinity. Starts with a v and rhymes with parable. Variable. You could use a variable. And we like to use n or k. So in reality, it's really the domain is all real numbers where x cannot equal. Do we really need to include 0? No. Where x cannot equal 2 pi n. Because when n is 0, there's an asymptote at 0. When n is 1, there's an asymptote at 2 pi. When n is 2, there's an asymptote at 4 pi. Do you see how that represents all the asymptotes? When it's -1, it goes in the negative direction. X cannot equal. Because what happens when x is equal to 0? There's an asymptote. It's not a part of the domain. Right? You can't have a point on the asymptote is not a part of your graph. Sorry, yes, I'll get to you.
Okay, since we're going this way, would it be plus or minus?
No, because what is n is -1? When n is -1, it's -2 pi. Right? Yes?
Would you have to have a thing saying that it is all integers, not like a fraction?
I'm sorry?
Would you have to have something saying that it is all integers and not a fraction?
Yes, you would probably, as far as the domain, where n is an integer would be a clear description. Yes, absolutely. Range, we'd want to include. Range is kind of getting something that we haven't really done as much. Range, how low does the graph go now? Negative infinity, all the way up to how high? -1. So that's negative infinity to -1, which is included. Then, for the second part of the graph, how low does it go? 1 to infinity. 1 is a part of the graph, infinity is not. So these two parts are both of your range, right? So we combine them with a union. Just like we did with domain back in the day for rational expressions. Right? Back in the day. Also, remember, you guys can see, does this have any absolute max? That's what I meant? No, but we have some relative max, a relative max. We have some relative mins. right? We see that the graph is bounded at certain integers. Okay, we can also see that the graph is decreasing and the graph is increasing at certain integers. Right? Remember, when you're labeling the integers of increasing and decreasing, you're only using the x values. Right? This graph is decreasing from 0 to pi. Right? It's decreasing from 2 or decreasing from 3 pi to 4. Right? Use your values. Yes? Huh?